In this video, we're going to review the book's implementation of a stack. And we'll actually see two different approaches to implementing a stack. The first will be using an array to store the elements in the stack. And then the second will use linked nodes to store the elements of the stack. Both of those are going to implement the StackADT interface, which includes the standard stack methods push, pop, peek, and then also isEmpty, size, and toString. So push, as a reminder, is to add something to the stack. Pop is to remove something from the stack. Why don't we call them add and remove? I don't know. We just don't. So that's what the add method is called, push, and the remove method is called pop. So with an array, remember we have to initialize that array with some size at first. And so we'll have a default capacity, which you can see here. And then in the constructor, we'll use that if no capacity is passed. Otherwise, we'll have a constructor that takes a capacity as a parameter. We create a new generic array with that size. Again, as a reminder, we can't have an array of generic object references, so we create a object array and we cast that to a generic type array. The top is going to point to the next available slot in the stack, similar to how an array list works, and that also serves to be the size of the stack. So we start off with 0, there's no elements in there, and index 0 is where you would put the next thing that's added to the stack. So our push method, first off, we're going to check to see if we have the maximum number of elements that we can store in our stack. We need to expand the capacity. Once we're done with that, then this top value is going to be pointing to the next open spot. So that's where we store the element in the array. And then we increment the top variable so that now is equal to the size of the stack, and it also is pointing to the next open slot in the array that we're using for our stack. To expand the capacity, we just call the copy of method, and what that does is it takes an array, so we pass it our stack, and then a new length, which we multiply the length times 2. We don't ever contract the array, but we double it in size once it gets full. So for pop, we're going to throw an exception if the array is empty, and we use the empty collection exception that we've seen before. We decrement the reference to top, so now we're pointing to that last element, and we get that result and then set that index to be null. Peek does pretty much the same thing, except that it returns the element stored at top -1. Again, top being the next available spot, so top -1 would be the spot in the array that's one before where that's next. And then the rest of these are ones that you should be able to figure out how to do. They're actually all identical to what you would do with an array list, and they're left as programming exercises. So our next implementation we're going to see is with a LinkedStack. And the LinkedStack, just like a linked list, will use linear nodes to hold the elements. And each linear node has a reference to another linear node. That's how we go from one node to another. And they'll also have a reference to some data, and that would be the element that we're storing in this node. So our LinkedStack has two variables. The first is going to be the number of elements in the stack, and the next will be a reference to the top element in the stack. When we call the constructor, we initialize the count to 0, and we say that top is null because there's nothing in the stack yet. To push, we create a new node, and we add a reference to that element that we're adding to the stack. We add that to the node, and then we set this new node's next reference to the existing top of the stack. And then we say that the top of the stack is pointing to that new node because it's the last element we've added, so that's going to be the next element we pull off, and we increment our count. Pop is going to do the opposite. It's going to take something off the stack. So again, if it's empty, we throw our exception, and otherwise we get the element from the top. Then we set top to be top's next. So this says now point to the next node, and we decrement the count, and we return that result, which is the element that's stored there. So if you're looking at this, you may be thinking this is very similar to a linked list, and you would be exactly right. This is essentially a linked list where we only add to the front and remove from the front. And if you look at our linked list implementation, you'll see that they're very similar to what's going on here, which again is why in a different video I showed you how to implement this stack interface using the existing linked list. So the other methods are not implemented, and it would be good practice if you want to try to implement these yourself. One of the ones that's interesting is toString, because here, since there is no underlying data structure, we really just have a reference to a linked node. So what you would need to do is actually figure out a way to traverse the list yourself. So that is the book's implementation of stacks using both arrays and linked structures.